All right, let's do this quick Unit 3 test review. We did this in class today. However, if you either weren't here or you still aren't quite sure about something, here's the opportunity to go through and have explanations as we go. So the first question, what does the lava lamp have to do with moving plates? Well, the lava lamp was our great example of the convection that happens in the mesosphere and the asthenosphere, all because of the heat from the outer core heating up this mantle material and making it convect. The crust sits on top of this material. So if this material, as it rises to the top like a lava lamp does, if that material is moving in a certain way, that's going to make the crust move that way. So what does the lava lamp have to do with moving plates? The convection of the lava lamp is an example of what's going on in our interior, and that makes our crust move. Here's number 2. What station is closest to the earthquake? Well, if it takes this much time for the first wave to reach station A, this much time for the first wave to reach station B, and only this much time for the wave to reach station C, then the answer here is C. It takes the least amount of time for the first wave to arrive there, and that's because C is closest to where the earthquake actually occurred. What plate motion is pulling Iceland in opposite directions? Use these arrows here as a clue to help you, and you should have this drawing in your plate motions note page. That is a divergent boundary, diverging. Those two plates are diverging. What map this map shows evidence of what? Well, this map is of the earthquake and volcanic activity locations all around the planet, at least the portion of the planet that this map is showing. Well, if we put a dot for all those earthquake locations and sites for volcanic activity, the dot to dots here reveal the shapes of the plates themselves. So this is evidence for plate tectonics. This is our earthquake locations, and it shows where the plates are, at least with a certain degree of certainty around the world. What is true about the epicenter of this earthquake? Well, if we only have data from 2 stations, the best thing that we can know is that the earthquake either occurred here or here. We're not certain which one because we're still missing data from a 3rd recording site. If we had another piece of data, we would have a circle around that site as well, and it would either align here or here, and that would tell us for sure where the epicenter of this earthquake is. But for now, with only 2 pieces of data, we know that the earthquake happened either here or here. All right, which power words should be used to explain how these volcanic islands were made? These are the Solomon Islands. They are, as this map shows here, north and east of Australia. Here's the Solomon Sea Plate, the Woodlark Plate, and the Australian Plate right here. And this marking on the boundary shows us that all 3 of these oceanic crust plates are converging and subducting underneath the Pacific Plate. With convergence and subduction here, you're going to get away from that boundary a little bit. You're going to get uplift. So the 3 words, hint, hint, 3, the 3 words that should be used to describe how these volcanic islands were made are convergent, with subduction, and uplift. All right, this diagram is a piece of evidence that supports which idea? Well, this is a diagram that shows the age of the rock on either side of the Mid-Atlantic Ocean ridge getting older and older the further away from the ridge you move. Therefore, this is an illustration of seafloor spreading, which is a piece of one of the founding pieces of evidence for the plate tectonic theory. Which earthquake is the most powerful? Well, all we got to do here is look at the amplitude of the S waves to know for sure, and these larger waves of the 3, and if this one isn't any larger than the first, we do know that S means secondary as well as shear. So the secondary waves, the second waves of these pairings would be where the S waves are. And we just look at the magnitude, and clearly this amplitude is very large. So that would translate to a most, of these 3 anyway, the most powerful earthquake is earthquake B because its S waves have a larger amplitude. So how was Hawaii made again? It says right here, hotspot. Hotspot is a mantle plume that has punched its way through the middle of a plate. It is not anywhere near an actual plate boundary. The boundary for the Pacific plate is outlined right here, so the boundary is very far away from Hawaii. So the mantle material has punched a hole through the Hawaiian island, or through the Pacific plate to make the Hawaiian Islands, and that plate just shifts on top of this mantle material and slowly creates a chain of islands, in this case Hawaii. This figure is evidence of what? Well, this is our plant and animal fossil locations matching between different continents that today are thousands of miles apart. So this supports the idea of continental drift. Number 11, one more to go after this. Why will oceanic crust always subduct continental crust whenever there is a convergent boundary here, and continental will not subduct oceanic? How come it's oceanic crust subducting continental and not the other way around? Well, the answer here is the oceanic crust is more dense than the continental crust. Continental crust is typically made of, if you had to categorize it, more of your granites, your granite-type rocks, and usually your oceanic crust is made of more basalt rock, which has a greater density. So the more dense rock is most likely going to plow underneath and subduct, going under, sub, under, sub. Subduct your continental crust, your continental plates here, and that will, of course, create uplift a little bit later away from the boundary. But oceanic will always do that on continental because oceanic is more dense. And this illustration, here's our last one, shows the progress of which theory? Well, as a great big clue here says Pangea, and then throughout the course of this timeline, the continents appear to drift apart. So this is the progress of the theory of continental drift. So there you are. All right. That is a rundown of some of the major topics that will be covered on your Unit 3 test. Good luck.